This is an HP41C, and in the top it's got some module bays, and in there you can put various different modules which give you additional functionality. This is a module. Ordinarily it's got a case around it. This one hasn't got a case. I've taken it apart, and the sort of general idea is, let me just put this in a case. The general idea is you have electronics in an enclosure, and this is an enclosure, and then you take your module, plug it in to the HP41C, and you can use whatever functionality is in the module. Now, internally the 41C has one of these, which is a plastic shaped block with a flexi circuit on it, and the connections on the module allow it to connect the 12 connections that are needed to the contacts on the flexi, and there's 4 of these, so it's sort of like that. Because of the shape of the flexi, where it goes around the edge there, and also the shape of the pins, there's a positive sort of engaging mechanism. And these are also springy contacts, so they push down onto the flexi and they actually push that way and give a good electrical contact. Now, this is a bit of plastic and a flexi circuit, and that's easy to make. So you can get new versions of these if they're damaged by battery corrosion, as this one had been. I put some copper sheet on there and soldered it on, which sort of worked, I think, maybe. But I've since bought new ones. I suppose, if you look at the module and you wanted to make a new module, a modern module, you could probably 3D print the housing to the connector, and that's what that is, 3D printed housing. You can 3D print the case, you can do that. The pins, however, are a bit of a problem. So after contacting a variety of companies around the world and getting quotes that were quite expensive, and also attempting to find out what these pins are made of, and at the moment my guess would be either brass or what I think is most likely is phosphor bronze, because phosphor bronze is quite springy. After having spoken to companies, they wanted to make it out of copper, and there's a copper connector block. Now this is a 3D printed housing. One of the arms is broken off because this is quite brittle. This is a resin print. I dropped it on the floor with no case on, so should be alright in the case. It's a 3D printed connector block together with pins which I've had made, which I've then hand formed, and it does work, but there's a few problems. One is that I hand formed it, so the profile's not ideal. Secondly, the pins are a little bit narrow. They're not exactly the same size and definitely not the same shape as these, so that needs to be handled somehow, which can probably be done. But the main problem is this set of pins is made out of copper. Now, I've tried CNCing sheet metals before, and copper in particular. I've done that with thicker sheets than this, and it's not it's not easy. There's a lot of problems with it, and you also need these pins in large quantities, so it takes a lot of time. So the way that the original manufacturers made them, I suspect these are just stamped out, stamped and formed on a machine that can make a million in the blink of an eye almost. So you've got some expensive tooling there. But there is another way of making pins like this, and that's to etch them. And that's how these were made. These were etched from a sheet of copper. You can see that there's a lot of pins there, and they're on a strip which is the same pitch as the pitch that they are in the connector, so you can have a go at assembling them in a strip form into some form of connector block. I actually, to make this one, I actually cut them off and put them through slots in the housing. So these copper pins could be gold plated. That would make them the same colour as these, but unfortunately they are just not as springy. You apply side force to it and it just bends and stays bent. There is enough spring in them to actually function as connectors here and not permanently deform. You can actually, and you can, well, I can feel it. I can feel the bump, the grab as it goes over that, over the feature on the end of the connector block. But it's nowhere near the same as these, so I think a different material's needed. So maybe brass, maybe phosphor bronze, that has to be sorted out, and then have another go. Then once that has happened, because this flexi is gold plated, it might be a good idea to have it gold plated on the pins so that you've got gold on gold instead of some other metal on gold. We don't want to damage this, although these are replaceable, so if over years it wore away, then you could actually replace this. It's not difficult to get new ones. So that's the state of play at the moment, and unfortunately at the moment it looks like you still have to get donor modules for pin blocks like I've done with my my prototype there. But it's looking fairly hopeful that if we can get the material right, that these will be manufacturable in a form where they perform very similarly to the original. But at the moment, even though this does work, if it's not hand formed, it would probably be better. You'd have a more reliable and a better entry onto the flexi, and also more contact force. But I haven't got my tooling set up for that at the moment. This is the sheet of copper, and this is half hard copper, so it's got a little bit more spring than just, well, soft copper. And you can see all the pins that have been etched on here, and I worked out, I think you could probably get something around about 1,000, 1,200 on a sheet of, or an A4 size sheet of copper. So maybe a little bit more, because the copper that's actually been used here, I've got a bit of copper down here which hasn't been etched, so I could have made the artwork larger, but there's various alignment marks and things that go on. So yeah, so you can get quite a few out of a sheet of copper, which is reasonably priced. I mean, there's tooling and things, so it's difficult to work out the price of a sheet of copper, but it's reasonable. The big advantage of this over getting tooling done in China or somewhere like that is that the tooling is very expensive. And it means if you've made a mistake, which I did do here, these are not wide enough, it's not the right size at all really. It needs to be changed slightly. If you do make a mistake, it's not particularly expensive. The artwork is much cheaper. I mean, there's still a cost there, but it is cheaper. So yeah, that's I mean, that's feasible. You don't need a lot of these. A few sheets of these, 5, 10 sheets would probably be all that's needed. So it's just a matter of getting those. Well, it's a matter of getting the design right, getting something that'll work with a material that is going to give enough spring and so on, and then sorting out the forming of it into the correct shape, and then maybe electroplating. I'm not sure how necessary that's going to be. But that's the pin project.